Today we are going to discuss about the seminar topic coagulation of concentrated milk. First we can see what is meant by a concentrated milk. Concentrated milk are products obtained by evaporating part of the water of whole or skimmed milk with or without the addition of sugar. Condensed milk is referred to as both condensed milk and sweetened condensed milk. The name are synonymous. This shelf-stable product is a form of concentrated milk in which about 60% of the water content has been removed, after which sugar is added before canning. Concentrated milk are made by the partial removal of water from fluid milk. These products are pasteurized and may be homogenized and are fortified with vitamin D. Now let's check what is coagulation of milk and how it occurs. Coagulation is essentially the formation of a gel by destabilizing the casein micelles, causing them to aggregate and form a network which partially immobilizes the water and traps the fat globules in the newly formed matrix. This may be accomplished with enzymes. This is the diagrammatic representation of how milk protein coagulation occurs. First we can see the milk proteins alpha lactalbumin, beta lactalbumin and casein micelles. It will undergo acidification in the presence of 0.5 mgdl, that is glucono-delta-lactone, result in two products MSF and MPF. Beta lactalbumin and alpha lactalbumin form milk suspension fraction, that is MSF. Then alpha lactalbumin, beta lactalbumin and casein micelles form MPF, milk pellet fraction. About 90.7% of milk protein coagulate into MPF. Coagulation of concentrated milk. The relationship between total solids content of concentrated milk and temperature time combination of heat treatment could be established using minimal heat induced coagulation as a criterion. Coagulation of destabilized casein micelles was shown to proceed non-linear over heating temperature. Heat treatment of concentrated milk system for preservation and long shelf life, or at least a sufficient removal of food pathogen prior to spray drying, is a crucial step due to the decreasing stability of these systems toward heat compared to unconcentrated milk. Heat-induced coagulation is observed when temperature-time combinations for the achievement for certain microbial inactivation effects are higher than the heat and colloidal stability of concentrated milk system allows. In this work, the effect of direct steam injection on the stability of casein micelles in concentrated skim milk (CSM) of 1823 and 27% of total non-fat solids heat treatment by direct steam injection were investigated. Quantitative separation was monitored by particle size measurement. The dissociation of K-casein as well as an increase in casein micelle hydrodynamic radius were observed to increase with increasing total solid content of concentrated skim milk, heat treatment time, and temperature. This is an equipment used for direct steam injection. It has a hot water outlet, mixing chamber, a nozzle, cold water inlet, steam inlet, a spindle assembly, and actuator. Heat-induced dissociation of beta-LGK casein complex at a critical level of 30 to 35% was found to induce severe coagulation of K-casein, depleted calcium-sensitive casein micelles in CSM heated by DSI, that is direct steam injection. Dissociated and aggregated proteins were found to be present as distinct colloidal particle classes differing in size from casein micelles. Now we can see how enzymatic coagulation of milk occur. Mainly there are three stages for enzymatic coagulation: primary stage, secondary stage, and tertiary stage. Primary stage. In the first stage, enzyme cuts off a specific fragment of one of the casein. At the natural pH of the milk, about 80% of casein must be cleaved to permit aggregation of the micelles to proceed. Secondary stage. Next stage is the physical process of aggregation of casein particle to form a gel. After losing its water-soluble tail, casein can no longer keep the casein particles separated, so they begin to form chain and clusters. The cluster continue to grow continuous, three-dimensional network which traps water inside and form gel. Third stage refers to ongoing development of gel network. For some cheese, the gel is cut as soon as it is firm enough to do so. Then acid coagulation of milk. Acid milk gels can be formed by lactic bacteria or the use of acidifying agents such as gluconodelta-lactone. GDL is slowly hydrolyzed to gluconic acid in the presence of water. Acid coagulation is used in the production of cottage cheese, baker's cheese, and quark, as well as other fermented milk products such as yogurt, commercial buttermilk, kefir, etc. In the case of cottage cheese and quark, a small amount of chymosin may be used to make the curd more elastic and less subjected to breakage or dusting. Now, heat acid coagulation of milk. This process permits recovery of casein and whey proteins in a single step. Basic principle is that whey proteins which are normally acid stable become sensitive to acid coagulation after heat treatment. This principle is exploited in the manufacture of ricotta cheese, paneer, and chana, and in the manufacture of co-precipitated milk protein concentrates. The basic process of heat acid coagulation. Heat milk or milk whey blends to at least 80 degrees Celsius for at least 5 minutes to completely denature the whey protein and encourage association of whey protein with the casein micelles. Continue heating and acidify slowly with a gentle agitation. The casein and whey protein will coagulate together and form either singing or floating curd.